Trying to get caught up on the videos I promised you. This is the video for the homework we had on January 10th, which really focused on finding missing measurements in a triangle using primarily geometric mean, altitude theorem, and leg theorem. So in problem number 1, we're finding x, which is the altitude of the larger triangle, so we're going to use the geometric mean altitude theorem. X times x is x squared. 6 times 8 is 48. So x equals the square root of 48, which if I put that in a calculator, that rounds to 6.9 as a decimal. If I want it in simplest radical form, I'm going to break the factors of 48 down. So we had 6, which breaks down to 2 times 3, and 8, which breaks down to 4 times 2. Let me change colors here so you can see what I'm doing a little bit here. 4, the square root of 4 is 2. 2 times 2 is 4, and the square root of that would be 2. So you put these on top here as a placeholder, then I can say 2 times 2 is 4 on the outside, square root of 3 on the inside. Had you realized that 48 is actually 16 times 3? 16 is a perfect square. Square root of 16 is 4, and again, you would get 4 radical 3. So that's problem number 1. For problem number 2, they're asking you to find part of the hypotenuse, and they've given you one of the legs. So we're going to use the geometric mean leg theorem. The leg, it goes in position 2 and 3. It's the geometric mean. Position 1 is the entire hypotenuse, which is 24. Position 4 is the part of the hypotenuse attached to the leg. That's 24 times b. Times the letter b equals 100. And 100, I have a calculator off screen here, divided by 24 is 4.2, is what that rounds to for B. For problem number 3, if you looked at the online work, I did a whole bunch of work. I set up a proportion and I cross-multiplied to solve, but really the altitude is the geometric mean of the two parts of the hypotenuse. So if I multiply 8 times 18, I get 144. And then I take the square root of 144 and I get 12. So the altitude is 12. But the altitude in this problem is represented by the expression w plus 9, and that equals 12. I subtract 9 from both sides. I get w is 3. So w equals 3. I wrote it there. Number 4, I at first had some problems with. Really, there were just too many variables going on here. They want you to find a number of things. Then when I looked again, I realized I have a leg. So if I use the geometric mean leg theorem, the first position here is 16. And the fourth position, the part that's adjacent to the leg I have, is x. So I can set this up and I can solve for x. And I have one of those missing measurements. So 14 times 14 is 196. And then 196 divided by 16 is 12.125. So I'm going to put that up here. X is 12.125. Now, if x is 12.125. And the whole thing is 16. 16 minus 12.125 is 3.75. And then Z, the altitude, is the geometric mean of the two parts of the hypotenuse. So I can actually take, I'm going to use a calculator on screen here so you can see what I'm doing. I can actually take 12.125 times 3.75. That equals that number. Take the square root of it, and I round to 6.8 for Z. Do 6.78 or 6.8, depending upon how I ask you to round. And that's that problem. Number 5. I don't have either leg. I have an altitude. And I want to find, the first thing I'm going to find is A, which is part of the hypotenuse. So using the geometric mean altitude theorem, I want to find A. That's an A. I think on the worksheet, a lot of you were saying, where did I get 9 from? It's not 9, it's A. And that's 24. A and 24 are the two parts of the hypotenuse. I'm going to cross multiply, and I have 24A equals 32 times 32 is 1,024. 1,024 divided by 24 is 42.67. So I'm going to round A to 42.7. Now, to solve for B, rather than start using a geometric leg theorem, I see that this triangle here is actually, B is the hypotenuse of a right triangle that has a side length of 32 and a side leg length of 24. So if I square each of those and add them together, I'm going to get, I want to find B. Now really, when we use Pythagorean theorem, that would be C squared. Is normally how we do it. I'm using the variable B here because that's what they labeled it. So 32 times 32 is 1,024. 24 times 24 is 576. And 576 plus 1,024 is 1,600. I want to take the square root of 1,600 equals B. So B equals 40. Now, to find C, I could do three different things. I could set up a geometric mean leg theorem. I could use C as a leg of this whole large triangle and use Pythagorean theorem, but I'm going to use C as the hypotenuse of this right triangle that has one side leg of 32 units long and the other side leg of 42.7 units long. 32 times 32 is said was 1,024. 42.7 times 42.7 is 1,823.29. I'm going to add those together, and I get 2,847.29 squared. So the square root of that is 53.4. Okay. If I want to check that, because there's a lot of decimals here, I should get that 53.4 squared, which is one leg of the large triangle, plus 40 squared, which is the other leg of the large triangle, should equal 42.7 plus 24, which is 66.4 53.7 squared. So I'm going to do 53.4 times 53.4 is 2,851.56 plus 1,600 equals 4,451.56. I'm going to take the square root of that, and I get 66.72, so that's certainly a 66.7. I've checked, and my problem works. Okay, I told you not to do 10 and 11. For this one, they want us to find AC and BD, depending upon where they are located. So first I decided I was going to find the entire hypotenuse here, because 30 squared plus 40 squared equals 50 squared. I know this, and I don't know why I've talked about it in all the classes, but there's something called Pythagorean triples. And if you have two legs with a side length of 3 and 4, the third is going to be 5. These are all whole numbers, because 9 plus 16 equals 25. Because you learned that 3, 4, and 5 are going to make a right triangle, if you take 3 and 4 and 5 and multiply them all by the same number, so let's say you multiply by 3, 3 times 3 is 9, 3 times 4 is 12, and 3 times 5 is 15, you're again going to have a set of Pythagorean triples. 9 squared is 81, so 81 plus 144 is 225. The square root of 225 is 15. So because I know Pythagorean triples, I know right away that if I have one leg is 30, one leg is 40, the other one has to be 50, because 3 and 4 are both multiples of 10, and then we would have 50 times 10. 5 times 10 would be 50. So now I have the whole piece. I have all of AC. I now want to find BD. Now the problem is, even though I'm finding BD, I can't just use geometric mean altitude theorem, because I don't know how this breaks up. And I can't use the leg theorem, because for the leg theorem, I need to know how this breaks up. But I can use what we learned at the very beginning of the unit about similar triangles and reorientating them. So I'm going to take this large triangle, and I'm going to orientate it so the right angle is to the right-hand side. When I do that, and I'm going to put the shortest leg on the bottom, the longer leg vertically, and the hypotenuse here. And to help me lay this out, that means the right angle has vertex D. The shorter leg is made up of A and D, and the longer leg is D to C. Now I can go ahead and take this right triangle right here, and I can see that this is the shorter leg, this is the hypotenuse, this is the longer leg. This longer leg, I'm going to call that L for right now, is what I want to find. So I can set up a proportion. I can take the hypotenuse of the smaller triangle, compare it to the hypotenuse of the larger triangle. Then I can take the leg that I want to find of the smaller triangle, compare it to the larger leg of the larger triangle. 50 times L is 50L. 30 times 40 is 1,200. And when I take 1,200 and I divide by 50, I get 24. So BD is 24, and AC is 50. That's problem 13. For problem 14, they want to find AC and BD. So to find AC, this is a right triangle. I'm going to say that this, I'm going to call this C. Actually, I'm going to call it A because it's one of the legs of the smaller triangle. A squared plus radical 6 squared equals the hypotenuse of radical 10 squared. Radical 6 times radical 6 is going to equal 6. And radical 10 times radical 10 is going to equal 10. That means that A squared is 4, A is 2. So if A is 2, the length of AC is 2. Now, next part of this. In the worksheet, I actually went ahead and then next found this part CD, but I thought I was finding BD. So there's a few different ways I can do this. I'm going to find CD so that then I can make a right triangle. So 2 over radical 6 equals radical 6 over x. 2x equals radical 6 times radical 6 is 6. X equals 3. The problem is on the worksheet, I put the 3 at BD. So now I have a few options. I can use triangle ABD and use Pythagorean theorem. I could use BCD. I could use the geometric mean leg theorem since I have 2 parts of the hypotenuse. I'm actually going to do that just to do something different with you guys. Haven't done that one. So I'm going to call this X. The leg is the geometric mean of the entire hypotenuse and the part attached to the leg. That means x squared equals 15. X equals radical 15. In simplest radical form, that is radical 15. In the computer, in the calculator, that's 3.87, so basically 3.9. And for the last problem, we want to find AC, which is the entire hypotenuse, and then we also want to find BD. So this one's a little bit simpler because they've given me the leg. AC is the length of the entire hypotenuse. I don't know that. I'm going to call that X. But I do know the leg, the part of the hypotenuse attached to the leg is a length of 35. So 5x equals radical 35 times radical 35 is 35. X equals 7. So AC, the entire thing here, is 7. That also means now that I want to find BD, which is the altitude, I need to use the geometric mean altitude theorem. I need to have both segment lengths on the hypotenuse. If this segment, it's not actually smaller, it's a larger segment is 5, and the total hypotenuse is 7, A to D is 2. So now I want to find BD. So 5 over X equals X over 2. X squared equals square root of 10, which is simplest radical form. And the square root of 10 is 1/6, so that's going to round to 3.2 if I have to round to the nearest tenth. So that should do it. That's a good help there. A good overview of the problems on this worksheet.